Cabrera. Vanessa, it's fantastic to see Colombia taking the lead in such an evolving field. It's very good work. Patricia is from the Ocean Best Practices System. She's the project manager of the Ocean Best Practices System, and she oversees the implementation of the project, ensuring that it aligns with the GOOSE and IOD work plans.
Thank you, Catherine. Okay, I would like to start my presentation with this image. I think it's a very well representation of today's landscape observing system. And in particular, with the rapid technologies advances, there's an emerge on data challenges and opportunities in the way we are collecting data. For example, the development of new sensors. It's providing not only new data types, but as well the amount of the data that is being generated by these sensors, in particularly imaging sensors, and as well how fast we are collecting and processing this data. It brings us a lot of new opportunities. For example, for plankton, to be able to capture the full size range of it, we need to use a lot of different instruments, and all these different instruments need to be cross-calibrated for the metadata and to be able to include all this added information, added value information into the international data repositories. So this different information coming from the different sensors bring us to the need for best practices. So all this sensor generating biodiversity information may have different ways of how the sample was collected, how the laboratory protocols to sample this process, to use the imager, if it was an in situ imager, for instance, as well how this imager is doing the identification of the species. So we can have, it can use machine learning, and you can also have a validation of this identification. So this is very important information that you need to capture in your database. As well, there is a lot of other information that you need to include, such as the concentrations in biovolume or density calculations, or other device-specific measurements. And all this is in order to have an interoperable data sets coming from different measurements. Next. So this is an image of the GOOSE BioEco portal that is gathering information on the long-term monitoring projects by EOVs. In this case, I filtered by plankton, zooplankton and phytoplankton EOVs. And as well, I use the filter to see how, if this data is transferred into OVIS. As well, you can find in the metadata behind these projects if there is a best practice that is informing about the methodology used to collect this data behind. So here you see in white all these projects. Next. Here we have another initiative where we can observe plankton data that is coming from Ecotaxa. This is a platform where you can import your images, and with AI you identify your species. So again, we see how there is a global coverage of data. And finally, the goal would be that all this data, following these imaging best practices, next, would end up in OVIS being harmonized. Next. So, but the way to get there, to our goal, it's very important to establish these best practices, to work together with cross-project collaborations, but as well with community review. And for the creation of these best practices in particular, there was a lot of work done together with data managers, sensor or instruments developers, the researchers collecting the data, all to be able to come up with the revision of what instruments are being used, what is the metadata behind this instrument, what is being generated, to be able to cross-calibrate it. We analyze as well what were the existing BODC vocabularies, as these new data types are also given the need of creating new vocabularies to be adapted in the obvious data formats. As well, the Darwin core terms and how to use them in order to have harmonized data, and data flows, because as I said, this data is being generated very fast and it's producing millions of images and millions of identifications that it needs to be processed and automated in a pipeline to be able to submit the data we need. So a key process here was community review and publishing the best practices in the Ocean Best Practice System, where now the goal is, after years, I have done a review of what researchers, data centers are following these best practices to understand how is the usefulness of this and what data has been submitted afterwards. Next. The first step was looking at the OBIS-EMP data format from the Potter et al., where we did recommend how to use specific Darwin core terms in the occurrence table, but more importantly, to be able to include all the metadata from the different instruments and the different methods used. We use the extended measurement of facts, the EMOF table, to include all the standards that are coming from BODC vocabularies, the worms taxonomy, marine regions, and TEDWEG. All this information is captured in these best practices that I'm showing here, but there's not the only ones. There is a few in the repository where you can follow and be able to format your data into OBIS EMP data format to submit to OBIS. Next. So as well, together with providing recommendations on how to format your data, we designed a data flow that starts from instrument, the imaging instrument, all the metadata coming from it, passing or bypassing the ecotaxa platform to classify the images. And then it goes into IPT, Eurobis, and later on to international data repositories such as EMONET Biology, OBIS, and GBIF. So after some time, this was created a few years ago. There are many projects that have been following these best practices, updating their data sets, such as the one in the left is more regional for the LifeWatch observatory data for zooplankton coming from the ZooScan, or the one here on the right that is from the Tara Oceans, that it has more global coverage. Next. So some projects that are following the best practices and updating and producing data sets or best practices or training for submitting data are LifeWatch Belgium, which collects plankton data, long-term plankton data, and it follows this data flow and format, populating Eurobis, OBIS, and GBIF. As well, there are projects such as Imaging, which it also provides imaging data set and training data sets for classifying your images. And as well, they produce best practices and training courses for anyone collecting imaging data sets. DTO BioFlow, that was already presented by Wen as well. They are awakening sleeping biodiversity data, and there has been, in particular, they are looking at new data types such as imaging or DNA-based data. And a new initiative that we're working now, we will start working now together. It will be with the ocean data sharing for using these use cases and promoting best practices within the ocean data sharing platform. So some key takeaways are that this standardized data enhances the accessibility, transparency, and efficiency. That community can take the full advantage of this data with the enhanced metadata from imaging. That it will be also very important to link these data sets to best practices to optimize interoperability and give visibility and be able to use more these best practices and have harmonized data, and encouraging a broader adoption of best practices to enrich these data repositories. So collaboration is essential to improve biodiversity data integration. And lastly, a call to action to engage, collaborate, and contribute to global biodiversity data standardization by using and developing best practices. Thank you.